All right, I believe I am live. Let's check that out. Let's see. Do confirm they can hear me. I think I see that Kinjal is signed in. Hello, Kinjal. Welcome back to Office Hours. Thank you for that suggestion of args parse yesterday. Hopefully you can hear me. And can you hear me? Just want to make sure. You are audible. Thank you. Thank you, Kinjal. Thank you for that confirmation. All right, like you might have caught it. Thank you for the suggestion of argparse. I think what I want to do is once we walk through this mini project, then let's go ahead and take what we've written out, package it nicely, and write a script that we can call on different data sets, perhaps the same content but different years, and it applies the analysis. Let's use argparse for that. All right, thank you guys. I see Naya is here. I see Lyndon Smith is here. Hello, Lyndon. Emmanuel. Joseph, I see Anna. Thank you for those confirmations. And Emmanuel, I think last time you brought up some issues with your pod. I looked into it, couldn't find anything wrong with it. But do let me know if you're still running issues. I want to make sure you have something you can work on. All right, guys, welcome to Office Hours, October 29th, where I am based. And with that said, a quick announcement that this Sunday, the U.S. will end daylight savings. So I know some countries don't do it. Some countries do it a week earlier. Some countries do it, or I'm being U.S. centric and saying that other countries do a week earlier. We're doing a week later, to be frank. So the office hours times will adjust so that they stay the same time in the U.S. It works better for the instructor schedule because we have other things scheduled, and it would wreak havoc if we keep the same UTC time. So those hours will be changed. Keep an eye out. Be aware of that. So for example, this morning office hours happens at 8:30 Eastern time where I am based. I think it happens, if I remember the UTC offset, I think it's a 12:30 UTC. Then it will happen, I think the UT offset will be 5. If that's the case, then it will happen at 1:30 UTC time. So keep an eye out for that adjustment for office hours, so make sure people don't get lost. Okay. All right, let's see who else is here. I see RD is here. Shakiba is here. Okay, and Kinjal is saying that they already did it in Europe. So, okay, yeah, I guess we're late, right? In the U.S., we're a week late. That's another way to put it. Let's see. All right, let me know about additional topics you want me to discuss for today's office hours or to put on the agenda. One of the things that I started building up, if you go to video downloads, you go to Office Hours Notebooks, there is a file called Project Topics. Oh yeah, I think, yeah, that's right. Mexico did it last week. My mother was telling me that. Although, correct me if I'm wrong, the border regions have not. So it can stay in sync with the U.S. Correct me, Naya, if I am wrong, but I think the border regions didn't do the adjustment. But let me know. That's what my mother was telling me. All right, let's see. I have some family in the border region, but I also have family in Nuevo León, in Monterrey, that region. Let's see what else is here. People put in the chat. Paulo, hello, Paulo. I see RDX saying, I saw your office hours yesterday. You mentioned jotting down important lectures that might be useful for our FLASK project later on. Can you mention office hours next every topic for reference in case we missed that one? Let's see. So what I'm going to do is keep in mind that the playlist, we have that thumbnail that we create with the topics, the main topics of the office hours. So I will make sure that when we talk about these project-specific ideas, these topics, that I do have that in the thumbnail, so it's very easy for you to reference it. And maybe since I can also put them here in this doc. So I would do that there. But I'm kind of creating a doc here that has those additional topics that we need to learn and discuss and understand before we work on that project or as we work through that project. All right, let's see. Anything else here regarding the first exercise on the DW? Go for it, Kinjal. Let me know your question. I see Tom is here. Hello, Tom. Ragaraj is here. And Ragaraj, I believe I answered your specific pandas question yesterday in office hours. So do take a look at it and do let me know if that's what you're looking for. But it was basically a programmatically way to create variables in Python. I see that WebD is here. Hello. Okay. Let me know any additional topics, things to throw up there. I think someone had a question on the first exercise on the DW, so do let me know. I think that may be a good segue as we pick up working on the DW mini project, so do let me know that question. Let me go into my server. Let me go into data course. Let me go into data wrangling, mini projects, and DW. All right. All right, looks like Atornum is back. Glad you fixed the software issue. Okay. All right, Emmanuel, glad that things are working back for you. And Kinjal has posted some code, so I'm going to go ahead and take that code. Let me go ahead and paste it and see what we've got here. All right, so of course, format it. All right. So let's take a look at what you've got here. We have a function called stats. It accepts a key, which is the column we want to process on. And we index and calculate the sum, the mean, the standard deviation, the quantiles, and so forth. And, you know, there's the other quantiles as well, but we won't have to enumerate all of them. And then what you did is you've iterated through and constructed your tuple using that function. And your question is, wouldn't this be easier and faster? And let me think about that. And it's probably, you know what, I think this is perhaps easier, right? I can see this being easier because it's more explicit on what's happening. Someone can take a look at this code and say, oh, you're calculating the mean, you're calculating the sum. By the way, if I can improve on this, we can use the built-in sum method of a series. There we go. That's just a small improvement, but the idea still holds. Yeah, I think the solution here is, I would say it's perhaps better than what I have. I like it because it's explicit. It's quite clear what we are doing for the fields. And actually, we don't need the min or the max or the count. These were calculations that weren't needed. So it just so happened that this was, I thought, a little more straightforward, but I do like this approach here. I do like it. So basically what we can do instead is define a function to return to us a tuple of the summary statistics of interest. And then have another process or maybe a list comprehension that iterates through and calls this function on the columns of interest. So yeah, so thank you, Kinjal, for sharing me your solution. I do appreciate it. All right, let's see what else we've got here. Yeah, you're unable to post it for the limitation. That's perfectly fine. We got the gist of what you got out here. So let's see, someone's asking for the data frame. We have views instead of mutating the data structure itself, but it did mention about in place. Is that applicable to only drop methods or all methods? Someone is asking about, and we'll see this when we get to more little pandas, is that in pandas, there are methods of a data frame, and by default, those methods of a data frame return a new data frame. Return a new data frame. However, you could, so for example, if I let me go ahead and run all, just so I can restart and clear all the output, get back what we've got. Do cell and run all above. And let's say I have scripts. I have my scripts data frame. And I decide to, I don't know, drop all the missing values. Let's say, I don't know, drop duplicates or something like that. When I do this, when I call this method, what gets returned is a new data frame. The original one doesn't mutate. It returns a new data frame. We will exploit this concept just in a bit later on in office hours. It returns a new data frame. However, a lot of these methods, a majority of them in fact, have a keyword argument called in place true. And what this means is that it will change the underlying data frame. So it won't return a copy, it will mutate, it will change this original data frame. The problem with this is this won't allow us to do method chaining, which we'll see in a bit here. So if for that reason, I rarely personally do in place equal to true. I always do something like scripts equal scripts.drop duplicates without the in place true, for the fact that this will prevent me, in place true prevents me to do method chaining, which will lead to some cool things, but we'll see in pandas later on. All right. Let's see. Hopefully that answered your question. I see that James is here. Hello, James. I see Wiki is here, Mr. Wiki. Let's see what another question here in the chat is saying. Also, can you talk about the lock method for the data frame and also iLock for indices? But if we can use iLock for names, does that make it case insensitive? So basically, let's go ahead and throw on the agenda lock versus iLock. A big sort of confusion when we work in pandas, so it's best that we take some time and clarify that. Okay. Okay, let's go ahead and move on. Let's see, I see another question in the chat. Yesterday we were working on the DWQ1. We transposed to enter the column names and we used names. I noticed that we were using index for the rows. Would that solution work if we ignore transpose approach? I didn't try it yet though. Let's see. Not sure I quite get your question, but the indices, every row has an index, and the index is the label for that row. So we can pick it up later, but let's go ahead and move on to Q2. Let's take a look at Q2, and what we're trying to figure out is the most common item. The most common item for, let's see, all throughout. So we can easily compute the summary statistics for each group of the data. In the PW, we had to explicitly construct the groups based on values of a particular field. Pandas will have that by the group by method. All right, so we want to calculate the total number of items dispensed for each BNF name. Now, every time you're working in pandas and you find yourself trying to answer, I want to do X for every blank. I want to calculate the average income for every state. I want to figure out the average population for every country in my data set. Every time I want to do X for every Y, what that tells you is that you need to do a group by method. You need to group your data frame. In other words, you take your data frame, you can kind of sketch it out right here. Here is our data frame. And what you want to do is you want to create groups. Create these smaller data frames. Take your data frame and break it up into that's a pretty bad picture, into mini data frames. And you group them by a given column or columns. So for example, we have a column of states and we group by state. What ends up happening is Pandas creates separate data frames for every value of state. And that's just an example. I'm grouping by states. Let's say I want to group by states in the US. So I have all these mini data frames where all the rows that belong to each of the data frames, they share the same value for the column state, since I decided in this example here to group by state. So we have Texas, which is my home state, born and raised. We have Massachusetts, where I currently reside. Washington, Alabama, Alaska, and so forth. So every time you find yourself, I want to do y for every x, think of group by. So in this question here, we want to find the total, the sum of all the items for each B and F name. So that means we got to take our scripts data set, scripts, we group by, and we say the column we want to group by. And I'll call that, I'm going to call this result groups, or grouped. And now we've got that. And now if we want to calculate the sum of a given column, we can treat this group by object like it were a data frame. So you know how you can index into a data frame by saying, hey, use the bracket notations, give it a column name. I can say grouped items. And if I want to calculate the sum of this column, I invoke the sum method. So I hope you can get an appreciation of the Pandas API. How it can group by a BNF name, index the items column, and calculate the sum. So the sum method, it's a function that belongs to an object, will calculate the sum of the items column, but for every group. So calculate the sum of items, but for every group. And here is the output. I'm going to go ahead and assign this to some variable name. I'll call it BNF total. And let me just go ahead and say BNF total head. So we can see the first 5 results. Now my question to you is, what do we observe here? What do we observe in this output? Think about the row labels. What do we see as our row labels? Well, they're truncated because we said head, but notice our row labels are the BNF names. So what the group by does is, if we group our data frame and we apply an aggregation, just like we have here, an aggregation is just basically saying I apply some method on the data frames, on the group, on those mini data frames I created. Notice the row labels are the values of BNF name, which makes sense because what I did is I've taken my data frame, and then I created groups based upon the BNF name. So I have these mini data frames for every different BNF name. And then what I did is I calculate the sum of the items column for each of those. And if we take the sum of a column, that's a single result. So basically we took a data frame and we collapsed it into a single result. So now after we apply sum, what you can think happens is we have a collection of BNF name and the sum, BNF name and the sum. A single value for every group. So then what we can do next, or what Pandas does next, it just puts them all together into a single series. We have BNF name and the sum of items. We're not quite done with what we need to do for this question. And that's what we see here. The BNF name and the total. Of course, we truncated it. We called head, so it only gives us the first 5, but here's a little more of them. Now what we want to do is we want to figure out let me go back to the question. We want to figure out the BNF name and the total that had the largest value. So there's several ways to go about this. So now essentially we want to sort this result here. We could say sort values. We can say sort values. And we say sort values, it sorts the series by set of values. Yeah, we see some duplicate. Look, I think it might appear to be some duplicates, but it's not quite because it's technically a different name. 10 centimeters, 20 centimeters. So they're not, strictly speaking, they're not duplicates. This sort values, by default, it sorts from ascending order, from lowest to highest. We want the other way around. So we'll say, I think it's ascending equals false. I believe that's how it works. I have to look at that. Oh, that worked. So notice I was able to get the correct order. So now we see that the BNF name that was prescribed the most is this drug here, and this is the total. Yeah, I thought it was, when you said it, I thought, oh yeah, we do have duplicates for some reason, but it's technically different. Yeah, a little tricky. So now we figured out the BNF name with the greatest total. And let's say we wanted to select one of what we have here is a series. You can think of it as an array. We'll call this BNF total sorted. I'll call this result BNF total sorted. And if you wanted to select one of those, let's say the top one thing we can do is we can use ilock. And this is, let's go into discussion between lock and ilock. Pandas is based upon indexing things by a label. Notice when we index a column, we don't necessarily provide the column name. The column position. For example, I say scripts, and let's look at head, and here are the top 5 rows of scripts. And if I want to index, for example, quantity, I just say quantity, the name of that column. I don't say scripts 0, 1, 2, 3, 4, 5, and 6. I don't say script 6. I don't say that. I don't index columns by its position. I index columns by their name. And this is a great behavior because who cares that quantity is column 6? Who cares? Right? It could have been column 1, column 2, column 0. I don't want to memorize or to determine what is the position of quantity. If I want quantity, I'll just index it directly. That's the beauty of pandas. It's unlike NumPy, where we have to say a given column position. Okay, same thing with row labels. If I want to index a row, I have to give it the name of that row, the index value of that row. If I want to index a given value in my data frame, I use lock. And lock stands for label locator. I index values of the data frame or the series based upon labels. What is a label for the row? What is a label for the column? So if I look at this here, there is a row called 2, and let's say I want from this row, I want the B and F name. So I would say lock 2, comma, the column name. Now it's a little confusing because the rows have 0 indexing. 0, 1, 2, 3, and 4. As we will come to see, that's arbitrary. We can give rows any label we want. Doesn't have to be 0 indexing. So it just so happens that the row of interest has a label 2. So we say 2, and we say B and F name. And there it is. So lock is label locate. Locate a value of my data frame based upon the row label and the column label. Any questions about lock? All right. Can we not do it without lock? Can we not do it without lock? You can say scripts. If I say scripts 2, scripts 0, this is by default a column name. So I'm saying give me column 0. So if you want to pull out a specific row and column value, you have to use lock. This here is for indexing columns, or series as they're called. And so key of 0, we get an error. We get a key error because there is no column called 0. Let's see, I say something like this. If I say that doesn't work out because there is no column called 0 B and F code. Now that's lock. Let's talk about ilock. It has somewhat similarities, but let's go and flesh it out. ilock stands for integer index locator. You use ilock when you want to reference values, index values in your data frame, not by their label as lock, but by its integer index position. The names are unfortunately very similar, so that is why when I say lock, label locator. ilock, integer index position locator. So what that means is if I want to index this particular value right here, well, it's in row 0, 1, and 2, column 0, 1. So I say scripts, messed this up. Put a new cell. I say scripts, ilock 0 and 0, 1. And I actually want the name, not the B and F code, 0, 2. Sorry, I wanted row 2. Row 2 and 0, 1, and 2. There we go. I think this should work out. And I get the same value. So here you're indexing things by its position, not by row label, not by its label, row label and column label. So that's the difference between lock and ilock. So you might be saying, which one should you use? You should really use lock. And the reason why you should use lock is because pandas, one of the philosophies behind pandas, is that we work with things by providing a row label and column label. We don't really care what position it so happens to be. we find things, we reference things by the row label and the column label. However, iloc comes into of importance when, let's say, we impose an order. We sort our data frame or series. And if we do that, then we can better reference things, better reference values by its integer index position, by its position. So for example, here we have sorted our data frame. We have sorted our data frame. So we can say iloc. We know that the value we want is at the top. So I can say iloc 0, and I get that particular value, the number. And if I want the label, I can say, let's say index 0. So now I'm able to pull out the label for that, the top result, and the value. Let me know if there are any questions. We'll go ahead and clean up this code, because one of the things you want to do is one of the things that will happen is that when we are experimenting, when we're doing our solutions, we get kind of things that are messy, but sometimes it's nice if we can put everything together. And actually there's a better approach to this here, which we'll take a look at. So someone is saying, what about scripts? What about scripts and BNF name and 0? Well, this should work out. And the reason why this works out is because you can read this from left to right. The first thing that happens here, is scripts BNF name returns a series. So then when we say bracket 0, that returns the row of the series with row label 0. So this should work out. However, I caution this approach. Don't use this. And the reason why is because this here is referred to as index chaining. And it's called index chaining because you index something and then you proceed to index again. And this might have some unattended consequences with regards to returning views and copies. This perhaps is for the further, a more in-depth discussion when the time arrives. But this here is a two-step process. You index and you return, you get a series, and you index that series. So what Pandas prefers you to do is to use the label locator, use lock, because lock is able to take this two chaining indexing into one call. So this is, so use scripts dot lock of 0 and BNF name. So this is the preferred method. Preferred and not preferred. I see someone here in the chat saying, how frequently do we use lock and iloc in data analysis? You use lock quite often, lock not so much. Lock very, very often, iloc not as much. And the reason goes behind, the idea behind Pandas is that we give our data labels. We give our row labels and our column labels. So let's use those labels when we want to refer to their values. Okay, so let's go ahead and get back to what we did here. However, what we did was kind of messy. I'm not sure about you, but what we did was kind of messy. So maybe there's a better way. So if I have my BNF total, and if I call the max method, I say max, and there's a min version, I say max. This will give me the max value of a series, which is what I want. but I want two pieces of information. I want the row label and the value. So what I need to do is, if sometimes you are interested in not only the max value or the min value, but the row label, what row it occurred, then we should use IDX max or IDX min. What IDX max and IDX min, it returns the row label with the max value. And that's what it is right there. So what this means is, what I can say most common item and say BNF total, that IDX max, and BNF total max. And I misspelled that. Most common item. So keep in mind, in pandas, if you want to find the row label that with the max or min, use IDX max. Any questions people have? Any follow-ups with what we saw right here? Let's just go clean up our analysis. So let's go ahead and I'm going to just copy this right here and paste what we have, so we can kind of have all our approach all in one cell block. Okay. Do let me know if there's any follow-ups. I'm going to go ahead and continue on. Oh, why does it give an error when we put in the grader? Good question, right? I had this. Let's go ahead and see what happens when I run the grader. I get a score of 1. So I'm not sure what's happening on what you have. I end up using index for the grader to work. Yeah, I have to see exactly what your code is, why it's going wrong, but this should work out. But do let me know. I'm kind of curious to see if we can fix that issue. All right, let's go ahead and move on, but I will take anything that pops up in the chat regarding Q2. So let's look at the items by region. This was one of those notorious questions that happened to PW. And let's take a look at what this question is asking. So let's find the most common item by postal code. And the postcode information is in the practices data frame. So we'll have to work with a new data frame. So this goes back to what we saw before. We have one data set called scripts that has the prescription information with the practice code. But if we want more detailed information about the practice, that's held in a separate data set. So we have to join those two together. And let's see what else we're asking for. And then return the result as postal code, the item name, and the amount of dispense as a % of the total. And we got to sort the results and submit it to the grader, first 100. But we also see here is that some practices have multiple postal codes associated with them. So use the alphabetically first postal code. Same thing we had before in the previous mini project. So in other words, what we want to do here for this question is we want to find for every postal code, so here's the postal code, what was the drug, the BNF name that was dispensed the most? So BNF name. And not only that, but the ratio. The number of items for that BNF name compared to all the items for that postal code. Basically the same question we did in the previous mini project. Of course, now we will do it in pandas. And as before, there are various practices with more than one postal code. So we got to fix this problem. And oftentimes, when we're doing data analysis, we have these things. We just have to make an assumption and work on it and go with it. So let's explore this. Let's explore this idea. Let's see. I'm going to go ahead and say print f string and say the number of practices. So what I can say practices shape 0. There's a shape attribute of a data frame which returns this number of rows and columns. So we index 0, which will give us the number of rows in our data frame. So a total of about 12,000 practices. And let's see how many unique practice codes we have. So anytime you want to figure out the number of unique values in a series, we're going to use the nUnique method. So I say practices and I say code. This is the series of all the practice codes, but if I want to find the number of unique practice codes, I use the nUnique method. nUnique, number unique. So number of unique practices code nUnique. So here we see discrepancy. We see there are about 12,000 practices, but about 11,000 unique practice codes. So there's certain records in there that are repeated twice, perhaps because they say, I don't know why. They have the same, I don't know why it's repeated, but we got to fix this. Right? These things happens when we're working with data. I see a question here is saying we should apply for module 2. Yes, you should apply to module 2. Make sure that when you apply, you indeed check Unit 2 box. Please make sure you check the right box, because if not, you don't want to apply to Unit 1 again. So please make sure that you check that box that says Unit 2. All right, Kinjal, glad you got it sorted out. Yeah, glad that worked out. So we got to fix this problem. We got to drop some duplicates. And we're going to call a duplicate one in which it has the same practice code. And luckily for us, there is a pandas method that allows us to drop duplicates. So let's try that out. So I'm going to say practices, and I'm going to say sort values by post code. So this here will sort my practices by my postal code. And we'll call this, I'm going to call this practices sorted. Practices sorted. And we'll take a quick peek at what we got there. And it looks like it seems to, let's see, I'm sorting it by postcode. But I really should, I'll sort it by postcode, because that's where we want to take the alphabetically first postal code. So that's the first postal code. That makes sense. I can use tail. Tail works just like head, but gives me the last 5. And that's what I have here. That appears to be the last 5. Okay, seems to be sorted. And what I'm going to say drop duplicates. Now when we say drop duplicates, what we also need to provide it is, how do we consider a duplicate? What is our criteria for a duplicate? Do all the do all the column names have to match up? Or do only certain column names have to be the same? How do we consider a duplicate? What is that criteria? We specify that via subset. We're going to call two rows as being duplicates if they share the same code. The same code right there. I thought that was an example of it. If they share the same code. In fact, I'm going to go ahead and say head of 20. Maybe I can see a situation where they are duplicates. Maybe I don't see one readily. Here it is. Here's an example. Notice they have the same code, but for some reason they are different, pretty much the same thing, right? Same postal code. It looks like their name is different. Yeah, it's just a re-entry in the data set. So what we're going to do here is we're going to drop those. And we want to take the one with the alphabetically first post code. So I say subset is equal to code. That is a criteria in which I flag a duplicate row. And then we have to tell it, well, if there's some duplicates, if I find multiple rows that are duplicates based upon my criteria, which one should I keep? So I specify a keep strategy via the keyword called keep. And if I set that equal to first, what that means is that I'm going to take the first occurrence of the duplicate. And notice that what I did previously is I sorted by postcode, alphabetically first by postcode. So when I say keep first, I'm going to keep the duplicate entry by whichever had the alphabetically first postcode. And I'm going to call this result practices unique. Practice is unique to refer to the fact that I now have unique practices. I fixed a problem, just like we had in the previous mini project. Let me know if there are any follow-ups here. I'm going to look at the chat. All right. Do we apply to Unit 2 if it is after December? So the deadline for Unit for the application is the 27th of December. So that means that, yeah, as long as you apply before then, you should be fine. But what I would recommend for you is apply as soon as possible. Apply as soon as possible, just in case you don't forget. Right, Unit 2 will happen, and Unit 2 will start January 18th. So make sure, but I will have to keep on saying this because it happens quite often, unfortunately, that when people apply, they forget to check the Unit 2 box. There'll be a box for Unit 2. Please check that box. You don't want to be Unit 1 again. Do let me know if that answered your question about the application process. Do let me know if there's any follow-ups to what we've done so far. We've got the unique practices. All right, okay, I see the email sent out was incorrect dates. I think that's, thank you, Paulo, for bringing that up. I think there was a typo in the emails that were sent out. So I understand, I think I get people's confusion now. Thank you, Paulo, for bringing that up. We goofed, we mess up, right? Unfortunately, that happens. Hopefully we don't make too many mistakes. But yeah, that was for the previous session. That is going on right now for Unit 2. So the correct deadline is December 27th. So sorry for that confusion. That's the next session that's coming up. And apply to it because some of the things we do here kind of build up to Unit 2. So it'd be very nice for you guys to continue on working on Unit 2. All right, so no problem. We sorted it, and then we did drop duplicates. But let's see if we can clean up what we did here. You might be saying clean up. That's pretty straightforward. 2 calls, all right? Well, let's exploit the fact that in pandas, when we call methods of a data frame, we return a new data frame. So what that means is I can chain method calls. Well, what does that mean? Well, let's go and try it out here. Let's go and try it out so we can better see what it means to chain method calls. So I'm going to say is practices unique is equal to practices sort values and say post code. So this here returns a new data frame from the sorting. And then what we want to do with that new data frame is we want to drop duplicates. So I say drop duplicates subset code keep first. So notice how I was able to condense this all in one line. And if we were to read it from left to right, what we read is, okay, we have a practice data frame. We sort by values. And notice what I'm highlighting right there is a new data frame that comes out. And what we proceed to do directly to that new data frame is we drop the duplicates. So read it from left to right. So we chain 2 method calls. And this is able to be accomplished. This works out because when we call these methods, new data frames get returned. And this will not be true if we had used that in-place keyword argument that we saw earlier. That's why people tend to shy away from the in-place keyword argument and use method chaining. And the nice thing behind this is that you can argue about the readability. I think it's a little more readable because we read things from left to right. But the other thing is we don't create these. Notice I create practice sorted and then I proceed to use it, but I'm not going to use it anymore. So what I've had here is I've clogged up my memory some object that I've only used once. Here I don't create that variable name anymore. All I have here is practice is unique, which is what I want. So that we're going to do some method chaining as we go through this mini project. Admittedly, method chaining is not be our first. We may not do it first using method chaining. In fact, when we work through these mini projects, we'll do it step by step like what we did here. But I do want to take the time to take what we have, that kind of scratch paper work, so to speak, and clean it up and do some method chaining and lead to a more readable solution. All right, so now let me know if there's any follow-ups right we got here, but let's see what we have done is we've created this unique mapping between practices, all unique practices. So we've got that mapping correct. And it's running. It says it's a typo, right? Typo. Okay, let's march on. But do let me know if there are any questions. So now what we want to do, and sometimes what it helps for me when we work on pandas, when we do kind of data analysis, I like to write out what is my plan of attack. I like to write it out, get it on paper, so to speak, understand what is our approach, and then take that outline and then see how we can translate it into pandas. That's what I do. I find that very helpful. Maybe you don't. Maybe you will. I don't know. So I'm going to share you my approach. Is outline our plan of attack and then start to execute it. Take that plan of attack and translate it into pandas. Translate to pandas. Funny thing, right? It's like, now I'm kind of curious to see what kind of noises pandas makes. But anyways, all right, so our plan of attack here is, first step is clean up practice data frame to only have one postal code. We accomplished that, and perhaps I should have outlined this before, but that was our first thing we did, and we took care of it. The next thing we got to do is merge in the scripts data. Got to merge in that data set, that data frame. Merge scripts and practices, the clean version, cleaned up version. And now once we brought in the scripts in practice data frame together, what we want to do is we need to figure out the total items for each BNF name and for each practice. Sorry, for each postal code. We want to figure out the sum of items for each BNF name and for each postal code. So that's what I have here, is calculate the sum of items for each BNF name and for each postal code. Then once I have that, then what I need to do next is calculate the total items for each postal code. That's going to serve as my denominator. And then calculate the ratio. And finally, sort the results and take the top 100. So that's my outline. That's my plan of attack for this question. So we did the first one, and now let's work on the second one. We're going to merge in the scripts and practices. So let's try that out. And I'm going to say scripts with post code, that post code information, is equal to scripts.merge. The way we merge in or bring in two data frames, you can think of merging as increasing the number of columns we have, is we use the merge method. And we have to specify the data frame we want to merge, which is in this case practices unique. Then we got to specify is the way we perform the merge. Is it a left merge, a right merge, or an inner merge? In this case, usually the answer to this question is we ask ourselves, what records do we want to be included? And what records do we want to be included if there are missing values? So in this case here, we want to keep all our prescription data. We want to keep all our prescriptions and bring in the practices, the right data frame. This is called our left data frame because it's the first one. I don't like this left-right distinction, but oh well, it's a convention. Scripts is our left, practice unique is our right. And when I say left on, we have to specify what is the column we're merging on. And if I look at my data set, scripts, I say head, practice is the practice code. And if I look at the practice data frame, I say head, it's called code. So in other words, we want to merge by practice on scripts and code on practices. We have to specify how we merge those two data frames. What is the column we use to merge on? So we say left on practices, right on code. And the method, the type of join will be, type of merge we're doing is a left merge. So we're going to say include all the records on our prescriptions, but merge in the practices that have a match. And we'll call this scripts with postcode. I'll run that there, and I say I got a key error. So a key error oftentimes means I reference a column that doesn't exist. Well, because there is no column called practices, I've had a typo, and I should probably learn how to spell better, but it's just called practice, no S's there. All right. We make mistakes. It's all about how we bounce from them, right? How quickly we can bounce from them. So I'm going to say, what's the difference between a merge and a join? So when you say merge and join, do you refer to the method merge and the method join? Or how they're used in, well, let me answer it both. In SQL, we'll talk about SQL in a couple of lectures, in a couple, I think in week 7. Join is the same and is the word you use in SQL to perform merges. In Pandas, they're called merge. Same thing. A join and a merge. A join in SQL, that's what it's called. Merge in Pandas. However, confusingly, there is a join method of a data frame. And I rarely use it, so I have to look at the documentation of what it does, but I believe join in Pandas is a way to merge in data frames based upon the indices, not necessarily columns. It's still the same operation where you take two data frames and you bring them together, but you bring them together based upon matching indices as opposed to matching column names, or whatever column name you provided. In Pandas, and this is, I'll say that merge. And here is the functionality of join. So since anything you can do anything with merge that you could do with join, I always just use merge. I don't bother with join for that fact. And it is confusing because join means something, it's the same thing as merge in SQL speak. It's confusing. I get it, unfortunately. So because merge can do everything that join can in Pandas methods, I just stick with merge. All right, let's see. I see a question here. Join scripts practices left on, right on code. Let's see. Yeah, I think that was pointing out my typo. Okay, so now I can say scripts with postcode head. And now I see that I brought in the information from the practices. There they are. So merging increases the width of my data. All right, so we did the merge. We're quite not there yet, but we're out of time, so we'll pick this up tomorrow. We should probably go through Q3 and make some headway on Q4. And after we wrap up this mini project, we'll clean it up and encapsulate it into a script that we can apply again and again with the same data set, but perhaps different years. So in other words, same column names, but different values. Repeat our analysis. That's what we really want to build up to. Encapsulate a workflow, a pipeline processing, and apply it for different data sets. Of course, same column names, but different values, perhaps of different years. So repeat this analysis. With that said, guys, we are over time. So thank you for coming to office hours. Take care. Have